Hello friends and welcome to another lecture on chemical engineering thermodynamics. Today we'll take up a problem which has come in Mumbai University May 18. It has come in chemical engineering thermodynamics 2 paper. The question is 2A. The question is the volume of an aqueous solution of NaCl at 298 Kelvin is measured for a series of molarities, moles of solute per kg solvent, and it is found that the volume varies with molarity according to the following expression, and the expression is given where m is the molarity, v is the volume in meter cube. Calculate the partial molar volumes of the components at m is equal to 0.1 mole per kg. Now, the solution for this is pretty straightforward. If we know the definition of partial molar properties. So, if V is a volume, let us say we have V as the volume of a mixture. Okay, so just a moment, guys. Let us say we have V as a volume of the mixture. And obviously, the mixture is going to be the summation of the moles. Okay, if V is the total volume, let us say V is the total volume, that is in meter cube, then it's going to be nothing but the summation of total volume of mixture is going to be the summation of the moles I into Vi bar, where I is equal to 1 to n, where there are n components in a mixture. Okay, if it's a binary mixture, n is 2. If it's a ternary mixture, then n is 3. So Ni is the moles of any component I, and Vi is the partial molar volume. Now, how do we get the partial molar volume? By definition, the partial molar volume is if we differentiate the total volume with respect to the number of moles of, let us say, component 1, holding component N2, N3, and so on, the all other components constant, then we have this differential is nothing but the partial molar volume of component 1. So we know that if we add up the partial molar volumes, product of the partial molar volume to the mole numbers, and if we add them up, we get back the total volume. So we have the expression for the total volume. Now what we need to do is only differentiate this expression. That is, this expression needs to be differentiated. Now V1 bar, that is the partial molar volume of component 1, is by what I had just explained now, V1 by dou N1, dou V by dou N1 holding N2 constant. It's because it's a binary mixture, which will be nothing but dou V by dou M. Here M is also in moles holding N2 constant, where N2 is nothing but the moles of water. Now differentiating this equation, this is the expression we get. Okay, now if we put M is equal to 0.1 in this expression, we get this value. Okay, and if we put 0.1 in this expression, we get V. Now we know that V is equal to N1 V1 plus N2 V2. I had just explained this concept. V is equal to Ni Vi, summation Ni Vi. So what we have is V is equal to N1 V1 bar plus N2 V2 bar, or V is equal to M, where N1 is nothing but M V1 bar plus 1000, because you have 1 kg of water, so 1000 divided by 18. So that many number of moles into V2. So your V2 is going to be 18.05 into 10 raised to minus 6 meter cube. So that was all about calculating the partial molar volumes of a mixture. Please like and subscribe my channel. This is very important to me. Also remember that your subscription makes this project viable. So far, the number of subscriptions that I have received is only 610. I need to cross the 1000 mark as soon as possible to make this endeavor successful and worthwhile my effort. So I request you to subscribe my channel, and I also request you to pass on my playlist and my videos to other undergraduate CET or even postgraduate CET students so that they get the benefit out of it. And also request them to subscribe my channel. That was all, guys. Bye.